Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for May-June 2024, and the code is 9709/52. Let's move on to question number 1. So for question number 1, Rajesh applies once every year for a ticket to a music festival. The probability that he is successful in any particular year is 0.3, independently of other years. A. Find the probability that Rajesh is successful for the first time on his 7th attempt. Okay, so basically 1, 2, 3, 4, 5, 6, 7. 7 attempt, and this is the first success. Okay, S means success, which means all the previous 6 will be failures. Alright, this is success. So now the probability, from here we know that success is 0.3. Alright, so now from here I will just write the P, which is a success rate, P success, that is 0.3. That means Q is 1 minus P, that is a probability of failure. This is 0.7. That means now here, right, the probability for this case, it will be probability he has 6 failures, right? First 6 attempts were failures. So it means that 0.7 to the power 6, because they are independently, means you multiply 0.7 for 6 times, and then lastly it is success for him. Therefore this is going to be 0.0353. So this is basically the geometric distribution. So I will say that X is geometric distribution with probability of success 0.3. Okay, now for B, find the probability that Rajesh is successful for the first time before his 6th attempt. So now X is geometric distributed with 0.3. Okay, so before 6 means X less than 6. X less than 6, I will write this is same as P, X less equals to 5. Now we have a formula. When X is geometric distributed with P, probability of success P, P X less equals to small letter x or lowercase letter x, this is 1 minus Q to the power of X, whereby the Q is 1 minus P. Okay, then from here, it will be 1 minus Q to the power of 5. Okay, and then the Q from the previous calculation 0.7. So which means this is 1 minus 0.7 to the power of 5. Then I will be getting 0.83193, and 3 significant figures, look at the 9, then I will get 0.3832. That is my probability of part B. Now see, find the probability that Rajesh is successful for the second time on his 10th attempt. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. This is my second success. Okay, that means for the first 9 attempts, Rajesh has 1 success and 8 failures. Okay, so now this is basically the negative binomial. So initially, 2nd success means P power 2. Okay, then you have 8 failures, Q power 8, and then out of the 9, I have 1 success. So I'm not sure which attempt will be the success. That means I will have 9C1. Okay, so that means this is going to be 9C1. Your Q is 0.7 to the power of 8. The P is 0.3, then power 2. Therefore, you will be getting 0.04669. And now I round up to 3 significant figures because the 9, so you round up, it becomes 0.0467. So that's the solution of this question. Now for question number 2, Siva has a coin which is biased, so that when it is thrown, the probability of obtaining a hit is 1/3. He has a bag containing 4 red marbles and 5 blue marbles. Siva throws the coin. If he obtains a hit, he selects 1 marble from the bag. If he obtains a tail, he selects 2 marbles from the bag without replacement. Now, A, find the probability that Siva selects at least 1 red marble. Okay, so now PH equals to 1/3. That means PT, tail is T, is 2/3. Okay, so you have 4 red, 5 blue marbles. Now, probability of getting at least 1 marble. At least 1 red marble, sorry. At least 1 red marble. So, 1 red marble, probably he obtains a hit. Right? Or probably, as I said, at least 1 red marble means probably 1 red or 2 red marbles. So, the R means red. Then now, okay, so P, probably I will write here, R means red marbles. B means blue marbles. Okay, so to get the 1 red marble, probably he gets hit first. And then he selects 1 marble and the marble is red color. Okay, or he obtains a tail. Then at the time he has to select 2 marbles. But then if let's say just 1 marble, 1 red color, it can be tail, then 1 red and 1 blue. This is for 1 red. Or probably 2 red marbles means that he obtains a tail and he selects 2 red marbles. Okay, because he has to select 2 marbles without replacement. Then from here, I will say that now to get the H, that is 1/3. To get the red marble, only 1 marble, 4 out of 9, because total here is 9. Or, okay, tail is 2/3. Now, first red marble, 4/9. Second, blue marble. I will not say second, I will say 1 blue marble. 1 blue marble, it will be 5/8 because you have taken 1. And then now, it can be red first or blue first. That means you have to times 2. That's why I write T and 1 red, 1 blue. It can be red first or red, blue or blue, red. That's why I times 2 here. Okay? Then plus, getting a tail is 2/3. So the first one, I mean the first marble is red color, so 4/9. And then second marble is also red color, becomes 3/8. So here you do not times 2 because same color. You will, in any draw, you will get the same color. So for the first case or the first calculation, that is 4/27. The second calculation is 10/27. And next calculation, 1/9. Then at last you are getting 17/27. Okay, just for information, this 2 is because of red blue or blue red. Okay, you may use this method or you can just use another method, which is using the combination. So I will say that my probability of at least 1 R, okay, for this part, it will be, now 1/3 is to get the H. Then to get the R, because you have 4, I will write 4C1, 4 choose 1, over total 9, choose 1. Okay, that is the probability of getting R, 1R, plus 2/3. That is to get the tail, right? And then now, 1 red. 1 red means 4 choose 1. and then times, then B, 5, choose 1. We can use this because you are selecting 2 marbles without replacement. So it means that you will not get the same marble. So when without replacement, you can just use the combination method. Then over total 9, choose 2. Okay, this is for the first R, 1R. And then the next one is 2 over 3. Then you multiply with, now 2R means that 4C2. 4 red marbles, you choose 2. Over 9, choose 2. So then you will be getting the same answer. 4 over 27 plus 10 over 27 plus 1 over 9. Okay, so at last, answer 17 over 27. So that's the alternative method to solve this question. Now B, find the probability that C1 obtains a head given that he selects no red marble. Okay, now because of given that is conditional probability, I will write P, probability 1 head, 1 H, given that no red, right? No red. So here, conditional probability formula is P A slash B, that is P A intersects B over PB. That means now here, I will be getting P 1H intersect no red, okay, over P no red marbles. So now, okay, if no red, right, that means, okay, or I said 1H first. To get the head is 1 over 3. So 1 over 3, since it is independent. Now, no red marble is basically green marble, right? Because when you get a head, he has to select 1 marble. That means this will be red marble. No red marble means blue marble. Okay, so here basically I will write P, H, and blue marble, and blue, over P no red. Okay, H and blue. H is 1 over 3. Blue at first 5 out of 9. Okay, look at here, 5 out of 9. So therefore the probability of getting blue is 5 over 9. Now for no red, okay, so no red marbles, you can just refer back to the previous calculation, at least 1 marble, 1 red marble. So from, I will just write here, from A, P at least 1 R, that will be 17 over 27. So if no red, okay, I don't want to consider all the conditions to get no red marbles. So it will be just 1 minus at least 1 marble. At least 1 red marble. Okay, so therefore this is going to be 1 minus 17 over 27. Alright, so you will be getting 10 over 27 here. So which means no red marble is 10 over 27. So from here, you will be getting 5 over 27 divided by 10 over 27. That is going to be half. So this is the solution of this question. Okay, next question number 3. The weights of oranges can be modeled by a normal distribution with mean 131 grams and standard deviation of 54 grams. Now, oranges are classified as small, medium, or large. A large orange weighs at least 184 grams, and 20% of oranges are classified as small. Okay, so now find the percentage of oranges that are classified as large. So now X is normally distributed, mean 131 and standard deviation 54. So I write 54 squared because your X is normally distributed with mean mu variance sigma squared. So when you standardize it, right, you will get X minus mu over sigma. So then from here, classify as large. Large means at least 184 grams. P x greater equals to 184. But since your x is normally distributed, the greater equals to is same as greater than, right? No difference because it is continuous random variable. So now I standardize it. So when you standardize it, you minus 184 minus 131 over standard deviation. Therefore, this is going to be P z greater than 0.981. So then, now sketch a graph. Bell-shaped curve. 0.981 is on the right side. Greater than means towards the left, towards the right side. That's the region. Then now here, the probability available, all the probabilities that are available in the table will be towards the left hand side. That means now here I have to use 1 minus all previous probabilities. So it will be 1 minus P z less than 0.981. So here is going to be 1 minus 0.8368. And now you will be getting 0.1632. Okay, now for the percentage. So this is a probability. So percentage equals to 0.1632 times 100%. Then you will be getting 16.32%. Now we always round up our answer, or we always leave our answer correct to 3 significant figures. That is 16.3%. So that is the percentage of the large oranges. Now B, find the greatest possible weight of a small orange. Okay, now small orange just 20%. Okay, so small orange means that the weights will be less than a number. Let's say the A is the greatest weight. Of a small orange. So Px less than A equals to 20%. And now I standardize it. So it will be Z, probability of Z A minus the mean remains 131 and standard deviation 54. So minus 131 over 54. This is 0.2. Now sketch a graph. So for your information, when it is Pz less than 0, it is 0.5. But now this is only 0.2 and some more this is less than. That means the region should be on the left side. Okay, because the probability is less than 0.5. So this line is A minus 131. A minus 131 over 54. Which means this is a negative value. So what I need to do is I reflect it to the positive side, which means you have to times a minus to the existing value. Okay, and then this region is 0.2 because the left side, the region is 0.2 here. So now I will write P z greater than negative of A minus 131 over 54 equals to 0.2, which means the previous region here should be 0.8. So that the total region here is, the total region will be 1. Okay, so now here I will just write B z less than negative of A minus 131 over 54. That is 0.8. And now read the table. From table, B z less than 0.842, it will be probability of 0.8. So now I just compare these two values and form one equation. Therefore, you will be getting negative of A minus 131 over 54 equals to 0.842. So now, to get the A, the negative 54 move to the other side. So I will write A minus 131 is negative 54 times 0.842. Then the minus 131 move to the other side. So A equals to 131 minus 54 times 0.842. So at last, this is going to be 85.532. And now round the answer correct to three significant figures. That is 85.5. So that's all for the A calculation. Okay, for question number 4, the back-to-back stem and leaf diagram shows the annual salaries of 19 employees at each of the two companies, Petra and Ravon. So now, this is a key. Find the median and the quartile range for the salaries of Petra employees. So there will be 19 employees. So now, n equals to 19. Median is half of the 19 plus 1. Okay, so this is going to be 20 over 2. That is data number 10. Now for data number 10, Petra. So label here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is data number 10. So now look at the key. 2/31/5. So it means that this is 31,200. So it means that now this is my median, which is 320. That will be 32000. Okay, because when you read here 312, then add the double zero. So now interquartile range, I need to get the Q1, lower quartile. So lower quartile, basically you have 9 data on the left side. So then you divide equally. So when 9 data on the left side, here first 3, then this is last 3, add one more, here add one more, that means this is my Q1, which is 31200. Okay, so we use the division method. 31200. Then my Q3. Okay, Q3, it will be the, you have a label. This is the top. This is the second top, third top, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, I know that it will be the fifth data. So it will be the fifth data over here. That means it's 34100. Okay, wait. 1, 2, 3, 4, 5. So my Q3 is, here will be 1, 2, 3. Oh, I label wrong. I circle wrongly. Okay, wait. Okay, here is 2. I label at the bottom, right? I label at the bottom. I better relabel it. Okay, I label on top. So 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9. So from the previous calculation, I know that is the fifth, right? From the lowest, and it will be fifth from the top. So that means it should be this value, which is 33500. So 33500. Now my interquartile range. That is Q3 minus Q1. So that is 33500 minus 31200. Then that is going to be 2300. Okay, done for the A. Now the median salary for Ravon employees is $33,800. Lower quartile is 32,000. Upper quartile is 34,400. Represent the data shown in the back-to-back stem and leaf by the pair of box and whisker plot in a single diagram. Okay, so now Ravon lowest is 302. Highest is 369. So 302. This one, 302, 369. This is the lowest. This is the highest for Ravon. So now for the Petra, the lowest is 300. So now here I will write for Petra, lowest 300. So highest, it will be 368. Okay, then the median, just now we have found 320. Then the Q1, 312, and the other one 335. 312, and Q3 is 335. Okay, so from here, I need to fix my interval. So lowest is basically 30,000. Highest is 36,900. Okay, so now here, if here is 30,000, 31, 32, 33, 34, 35, 36. This is 37. Okay, so here 31,000, 32,000. This is 33,000, 34,000, 35,000. This is 36,000. And lastly, 37,000. Okay, so now just draw a line here. Okay, so from here I know that the difference here, right, the difference here is 31,000 minus 30,000. That is basically 1,000. Okay, and there are 10 squares, so divide by 10. So I know that each square is 100, right? So 100 per square. So then for the Ravon, okay, I draw Petron first. Lowest is 30,000, so 30,000 lowest. Highest is 36,800. 36,000, so 800. And then the Q1, 31,200. 31,200. Then the median, 32,000. Then after that, 33,500. So join this. This is a box, and whisker. This will be the whisker. So here I will label Petra. Now, for Ravon, the lowest is 30,200. So 30,200. 200 means 2 dots. Okay, after that, the highest, 36,900. Right, so now your lower quartile, 32,000. So 32,000 is over here. Then the median, 33,800. So 33 here, so another 8. Lastly, the upper quartile, 34,400. 34,400. So this is Ravon. Okay, so done for the back to back stem and leaf okay, done the box and whisker plots. Okay, now part C, comments on whether the mean or median would be a better representation of the data for the employees at Petra. So look at the Petra. Okay, so we use mean when it is symmetrical. Okay, we use median when it is not symmetrical. So obviously it is not symmetrical, right? Or probably you can say there is an outlier. Okay, so you see the highest value is so much difference from the rest. So here I will just write median. Okay, because as the distribution is not symmetrical. Okay, or you can say there is extreme value. So when you look at the data, the original data, majority are between 30,000 and 34,000, but suddenly one is 36,800. Or probably here you can just write or there is an extreme value. Okay, so now next question, number 5. Jasmine has one $5 coin, two $2 coins, and two $1 coins. She selects two of these coins as random. The random variable x is the total value in dollars of these two coins. Okay, now A, show that px equals to 7 equals to 0.2. So now here, px equals to 7, I could say that means total is $7. So it will be $5, then $2, or $2 and then followed by $5. Okay, so one $5 coins means that P, now here I will just write 1, then two $2 coins, and then two $1 coin, $1 coin. So now $5 coins, that is 1 out of 5 because total is 5. $2 coins will be 2 out of 4 because I have taken the $5 coin. And then the next one will be the same. So at first 2 over 5 and then 1 over 4. So this is going to be 1 over 5, and which is same as 0.2. So we have shown it. Okay, now B, draw up the probability distribution table for X. So for the X, now here you have to consider the total, okay, total amount. So which means now here, since you have $2 sign, $5, $2 coins, then $1 here. So I know that the minimum X, the minimum total is 2. 2 means that you are getting $1 each because the question says she selects 2 of the coins. So $1 each means that it will be 1 over 5 times, 2 over 5 because there are two $1 coins, then 1 over 4. Then you will be getting 1 over 10. So I can say that after $1 plus $1, it can be $1 plus $2. So you will get x equals to 3. When x equals to 3, obviously it's $2 plus $1 or $1 coin plus $2 coins. So that means here $2 coins will be 2 over 5. $1 coin is 2 over 4. Okay, so you can just times 2 because $1 first and second and $2 second, it will be the same. So that means here you can just times 2. Okay, 2 arrangements. Therefore, this is going to be 2 over 5. Alright, I'll put it in decimal. So this is 0.1. Here is 0.4. Now, I can say I will be getting $4 coins as the total. So it must be $2 plus $2. So it will be 2 over 5 times 1 over 4. Then this is going to be 1 over 10, which is 0.1. Okay, after that, 5 plus 6, 5 plus 1, that is $6. So that will be 5 plus 1 or 1 plus 5. Okay, so 5 plus 1, at first to get to 5. 5 is 1 over 5. Then left 4 coins. $1 is 2. Okay, then you just times 2 because the arrangements, same probability later on. Then here it will be 1 over 5. That is 0.2. Okay, together with the px equals to 7 just now, that will be 0.2. Okay, so now from here, the probability distribution table of x, that will be x values probably and the probabilities. So I get 2, 3, 4, 6, and 7. So the probabilities will be 0.1, 0.4, then 0.1, 0.2, and 0.2. Now, how to check whether this table is correct or not? You just add up all these probabilities. Make sure it is 1. Okay, so done for this question. Okay, now next question, find the value of variance x. So I will rewrite the table. Okay. So now my variance x, before I get the variance, I need to get the expected value. Expected x is actually summation x px. So which means you multiply the x with the p first. So multiply all this and then you plus all. So which means 2 times 0.1, the summation, it means plus. So 3 times 0.4 plus 4 times 0.1 plus 6 times 0.2 plus 7 times 0.3. Then here you will get 4.4. And then the next calculation is ex squared. So this is summation x squared times p. So means follow the previous calculation, all these calculations, just square the x. So I get 2 squared times 0.1 plus 3 squared times 0.4 plus 4 squared times 0.1 plus 6 squared times 0.2 plus 7 squared times 0.3. Then here you will be getting 22.6. So now my variance x is basically ex squared minus square of the ex. Then you will be getting 22.6 minus 4.4 squared. And this is going to be 3.24. Okay, question number 6. The residents of Margin were asked to classify their local bus service. 25% classify the service as good, 60% as satisfactory, 15% as poor. Now, a random sample of 110 residents of Margin is chosen. Use a suitable approximation to find the probability that fewer than 22 residents classify their bus service as good. Okay, so now n equals to 110. Probability of good is 25%. So that means 0.25, which means the Q is 1 minus 0.25. This is 0.75. Now initially it was binomial distribution because number of residents. Okay, so number of residents is discrete random variable. Therefore now, because of the n is large, you see, this is greater than 50. Alright, so now I need to check what is my NP. NP is 110 times 0.25. This is going to be 27.5, which is greater than 5. Therefore, it will be normally distributed. So for the normal distribution, I need to get the variance. My variance is NPQ from the binomial. So my NP is 27.5 times by the Q 0.75, and you will be getting 20.625. And now here I will write X initially binomial distributed with mean 110. P is 0.25. Now it has been approximately to normal distribution. The mean is 27.5 and the variance is 20.625. Okay, now less than 22 residence. So now P X less than 22. So from binomial, you approximate to normal. Binomial is discrete. Normal is continuous. So from discrete to continuous, you need to carry out the continuity correction factor, which is here 22, but X less than 22 means 21, 20, and so on. So you are allowed to plus or minus 0.5 from 22. So either 22.5 or 21.5. But now we look at the sign here, it is less. The inequality sign is less. Therefore, I must follow back the less. So obviously, I have to choose less than 21.5 to include the two ticks. So here, 21.5. And now, since the W is normally distributed, then we standardize it. Z less than 21.5 minus 27.5 over square root of 20.625. Then here, you will be getting P Z less than negative 1.321. And now I sketch a graph. So when less than negative 1.321, this is the region. The region is towards left hand side. But then since it is negative value, it is not available in the table, in the normal table. So I flip it to the right side and I'm finding the region on the right side, which is the orange color. That means this is same as P Z more than 1.321. Okay, and this orange color is same as total probabilities 1 minus the previous probability. Therefore, this is 1 minus P Z less than 1.321. And read the probability from the table, you will get 0.9068. Now when you round up, you simplify, this is 0.0932. So this is the probability that we need to calculate. Now B, for a random sample of 10 residents of margin, find the probability that fewer than 8 classify their bus as good or satisfactory. Okay, so now good or satisfactory means that you need to add. That is, okay, good is 25, satisfactory is 60. So that means 0.25 plus 0.60, that is 0.85. That means now your P is 0.85, your N is 10. That means your Q is going to be 1 minus 0.85. So I'll get 0.15. Now, since it is still residence, okay, your N is small, less than 50. So I will solve this question using binomial distribution. So N is 10, the P is 0.85. Now less than 8 out of 10. So Px less than 8. Less than 8 supposedly from 0 until 7. So now for your binomial, for your knowledge, binomial distributed, the probability is NCX, PX, QN minus X. Your X start from 0 until N. So less than 8, I don't want to calculate from 0 to 7. I will write 1 minus all all the rest. So all the rest will be 8, 9, and 10. Because you are actually calculating the probability from 0 until 7. So the remaining will be 8, 9, and 10. So now use the formula. Px equals to 8. right, refer to this formula. That will be 10C8. Your P is 0.85. There are 8. And then Q is 0.15. There are 2. Because 10 residents, 2 failures. It will be 10C9. Then 0.85 degree 9. 0.15 degree 1. And lastly, 0.89 degree 10. It's 5, not 8, 9. This is 5. Okay, then now when you calculate, it will be 1 minus 0.275897, then plus 0.347425, lastly 0.196874. So here it will be 1 minus 0.820196. This is going to be 0.179804. Now I round up to 3 significant figures. So since the next one is 8, so you round up, 79 becomes 80. So 0.180. That is the probability of this question. Now 3 residents of margin are selected as random. Find the probability that 1 resident classified the bus as good, 1 as satisfactory, and 1 as poor. Okay, P good just now was 25%. So good is 0.25. Satisfactory equals to 60%, so 0.6. That means poor, this is 0.15. Okay, so now since 3 residents here, so now my probability, it will be P good times P satisfactory times P poor. Then now since there are 3 persons here, okay, 3 residents, so we are not sure which one is giving the good, classify the bus service as good. Okay, so this I have to arrange these 3 persons. So since there are 3 different persons, so I times 3 factorial. So therefore it will be 0.25 times 0.6 times 0.15, then you times 3 factorial. So at last you will be getting 0.135. Okay, now question 7a, how many different arrangements are there of the 10 letters in the word regenerate? So regenerate, there are 10 letters. Out of 10 letters, you have 1, 2, 3, 4. 4 E's. And then you have 1, 2 R, 2 R's. And then the rest will be G, N, then T, or AT, G, N, AT. Okay, so now you are arranging all 10 letters. So number of arrangements, it will be 10 factorial over 4 E's and 2 R's. So here you will get 75600. Now B, how many different arrangements are there of the 10 letters in the word regenerate in which the 4 E's are together and the 2 R's have exactly 3 letters in between them? Okay, that means now here I will write the R, then 3 letters, the R, probably 4E. So when the 4 E's are together, I group them as 1. So now 1, 2, 3, 4, 5. 5 plus 4 means 9. You still have 1 more letter. Okay. And then now, because we have 4 E's, right? So impossible 4 E's to be in between the 2 R. Because the 2 R's only has 3 letters. So now I will say that probably the first one is not R, but the second one is R followed by 3 letters, and then this is R, and here is 4 E's. Okay, and probably the first two are not R, then R, 3 letters, and then here is R. Now, for your information, from here, I'm going to choose from G, N, A, T. Okay, for these 3 letters in between. So because you only have 2R, 2 R's, 4 E's, and these 4 letters, so then from here, I will say number of arrangements, right? Number of arrangements equals to, now for the first case, to calculate these 3, I will say 4, I choose 3 and arrange. So that is 4p3. Okay, after that, since the R already fixed, so we are not going to arrange the R anymore, right? And there is no difference between the 2R. And now here, don't forget, this 4 E's and the other remaining letter here, you can swap. That means now 4 E's is considered as one letter because they are together. So you can swap these two, last two, therefore 2 factorial. Okay, that is for first case. All is plus. Now again, the middle one, I will consider the middle one first. This will be GNAT. So here GNAT, you choose 3 from 4. Therefore, I will be getting 4p3. Okay, now again, this 4e, right? This 4e and the first one can be swapped. So it will be 2 factorial. So after you have chosen 3 letters to be in between 2 R's, so let's one more. So that one no need to choose. Okay, that's why I will just direct arrange with the 4e. So that is the 2 factorial. Same goes to the last one. Okay, so here probably this is 4e. Right? And then the 4e also can swap. So basically, I'm getting 4p3 times 2 factorial. So then now, here is basically 4p3 times 2 factorial times 3. Okay, then here is actually 24 times 2 times 3. Then you are getting answer of 144. So this is the first method. Okay, if you don't want to use a 4p3, now you may write in this way. So number of arrangements Okay, so for these 3, right, for these 3 lines, I will say that at first, I have 4 choices, right, because GNAT. So I have 4 choices for the first digit, first letter in between R, 2 R's. Then after I have chosen 4, I mean 1 letter, the next one I have 3 choices. Then the last one, the third letter in between the 2 R's, I have 2 choices. This is for the 3 letters in between R. Alright, then now for these 2, okay, I will have 2 factorial. Okay, 2 factorial here, 2 factorial, because to arrange 4 E's. And then I have 3 cases, 1, 2, 3. So I just times 3. Basically, instead of writing 4p3, you can change to 4 times 3 times 2. It will be the same. So then the 2 factorial and the 3 will be same as the rest. Right? So for your information, 4 times 3 times 2 is actually 4 factorial because our n factorial is n factorial is n times n minus 1, n minus 2 until 1. So 4 times 3 times 2 is same as 4 times 3 times 2 times 1. That means here you can just write 4 factorial. Okay, 2 factorial times 3. Okay, 2 factorial is basically 2 times 1. If 3 factorial, that is 3 times 2 times 1. So here I can say that it is 3. This is 2 factorial. So that's why 3 times 2 factorial is basically 3 factorial. So you can just write times 3 factorial. That is 144. So same answer, same meaning. It's just that instead of writing 4p3, you write 4 times 3 times 2. You consider how many choices for each for each letter. Okay, so these are the two ways, two presentation of the solution of this question. Okay, now see, find the probability of a randomly chosen arrangement of 10 letters. This is a probability in the word regenerate is one in which the consonants and vowels alternate. Okay, so you have listed down. You are given the vowels and consonants. You need to get alternate so that no consonants are next to each other and no vowels are next to each other. Alright, so which means now here consonants let it be C, then it will be G, N, R, R, T. Vowels, let it be V, that will be A, E, 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 E. 4 E's. Okay, it's mentioned consonant and vowels alternate. So it will be CV, CV, consonant, vowel, and so on. So 1, 2, 3, 4, 5. Or probably VC, 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 VC. This is 1, 2, 3, 4, 5. V1, V2, V3, V4, V5. Okay, and now I need to calculate the probability. So the probability is basically, now to get these two arrangements, so basically for the consonants itself, right? Consonants itself. Look at the consonants here. I have 5 consonants here, 5C. I have 5C, but 2R. Okay, I have 5 vowels, but I have 4 E's. So it means that I'm actually arranging C1, C2, C3, C4, C5, all five consonants. Therefore, there are 5 factorial, but out of 5 consonants, there are 2 R. Okay, 2 R's. And then followed by means the second task is to arrange the vowels. So again, 5 vowels, but there are 4 E's. Okay, now here, I go to times 2, because times 2 means that you can start with consonants or start with C. So over the total arrangements. So probability is always PA equals to NA over NS. NA is a number of elements that satisfied by the A. The NS is the all possible outcomes, right? So the times 2 is because of you start with 2, you start with V, or you start with C, right? So now for the total, we have done it in previous part. That is from A, 75600. Okay, that is without restriction. So I will just divide by 75600. That means you will be getting 60. Okay, this is going to be 60 times 5 times 2 over 75600. Therefore, this is going to be 1 over 126. So that is the solution for this part C. Okay, so that's all for this paper, and it also comes to the end of the video. Thank you everyone for watching my video, and please subscribe to the channel and share this channel with everyone. Okay, so and also stay tuned for more upcoming videos. Thank you. Bye.